Welcome to the class of Macro Radar Engineering. This is video lecture number 3 and we will continue with the transmission line. I am Mr. Himanshu Nagpal, Assistant Professor in EC Department of AKGEC Ghaziabad. Now first we will continue with the transmission line. In the last lecture we had started the theory of transmission line. Now transmission line is an electrical signal which is electrical signal propagating medium between transmitting end and the receiving end. Now see, consider this one is a transmission line and this one is source side and this one is the receiving side. Yes, or you can say receiving end. Clear? And let's say this transmission line having a length L and this one is what? Z equal to 0 and this is maybe the position that will be equal to Z equal to L. Clear? Now see, as I have already told you in the last lecture that voltage and current are a function of what? Position of Z. So voltage and current will be the function of Z, and if I say that terminal voltage is expressed in the time domain, that is V of Z comma t will be equal to V of Z equal to j omega t, and similarly the current which is flowing in this circuit will also be a function of Z comma t, that will be equal to I of Z e की power में j omega t, because terminal current and terminal voltage is expressed in the time domain. And let's say this source has source impedance that is known as ZZ, and this terminated impedance is given by the ZL. Now see, at any point of Z, now see, if I say this is a transmission line, here Z equal to 0 and this one is Z equal to L, and in between let's say this one is D equal to L and this one is D equal to 0. If I say this one is the direction, then this may be the L minus D, and this one whole length of this transmission line will be L. Now see, this is the incident current that is shown by II in this direction, and this one is the reflected current which is in this direction and denoted by IR. Clear? Now this one is the source voltage that is given by VG and having a source impedance that is given by ZZ, and at the load side this load impedance is given by ZL, and IL load current will be directed towards this one. Now see, this one is the incident voltage or the incident direction, and this one is the reflected, and this reflected voltage or reflected current will occur only when there is a mismatch at the load side, means the impedance when there will be a mismatching of impedance. Now see, at any point of Z, the voltage will be a function of Z and the current will also a function of Z. The total voltage and current on the line given by superposition of incident or forward travelling wave. Clear? And in superposition of incident and the reflected wave means V of Z will be equal to V of I e की power minus gamma Z plus में V of R e की power में gamma Z. Similarly, the current will be equal to incident current e की power minus gamma Z plus में reflected current e की power में gamma Z. Now this e की power gamma minus gamma Z represent that the voltage is in this forward direction, and this e की power gamma Z will show that the voltage is in this direction from receiving end to the source end. Clearly? Now see, this one will be equal to minus of R, this will not be plus, this will be minus of R. Why it is minus of? Because the incident direction of incident current is in this direction and direction of IR current, reflected current, will be in this. Both are opposite to each other. That's why I am saying that I of R is having a magnitude of having a negative sign. E की power gamma Z represents that the wave is propagating in this direction from receiving to source end, and here minus gamma z represent the forward traveling wave, means the wave is traveling from source to the receiving end. And what is gamma? Gamma represents the propagation constant. Vi and IR are the wave amplitude of the traveling wave along plus z direction and minus z direction respectively. Clear? Now see, we will talk about the transmission line equation. Now before we are starting the transmission line equation, we will see the equivalent circuit of the transmission line, because now see a small length of this. Now if I say this one is a transmission line, this one is z equal to 0 and this one is equal to z equal to L. A small portion of transmission line, a small position, let's say if I say this one is z equal to, here at I say if z equal to z dash, and then here z equal to z dash plus me delta z. Clear? So small length of line is represented by the equivalent L section network between the L section network with parameters R, L, G and C. Clear? Now what does R? R represents the ohmic losses in the line, L represents the magnetic energy storage around the conductor, and G represents the conductance per unit length, and C represents the capacitance per unit length, which is appears due to the two conductors at different potential and electric energy storage. Clear? So this will be the equivalent circuit of a small portion of transmission line. Input voltage, let's say V of z comma t, and similarly at the output V of z plus me delta z comma t. Clear? And here if I say the position is z, so here the position will be z plus me delta z. Clear? So the small portion of transmission line is given by delta z. Now see, this one is the resistance per unit length. So overall resistance will be R into me delta z. Inductance will be L into me delta z, because inductance is per unit. L represents the inductance per unit length, and similarly G and C represent the conductance and capacitance represent per unit length, and the overall capacitance will be C into me delta z from this transmission line, this small portion of transmission line, and G represent the conductance, that will be G into me delta z. Now we will find out the transmission line equation. Now first apply this. Now see this one, apply the KVL rule. Apply KVL. On applying the KVL rule, you will say that V of z comma t plus में R into में delta z plus में L into में delta z plus में V of z comma plus में delta z comma t will be equal to 0. So V of z comma t minus में R into में delta z I z t minus में L into में delta z d I z by dt minus of z plus में delta z comma t will be equal to 0. Clear? Now see, now apply the KCL rule. Just represent this as, I can say that will be equal to apply the KCL rule at this node. This is G into my delta z and this one is C into my delta z. Now apply the KCL rule here in this direction. You will see that I of z, this one is I of z, and this current represents what? I of z plus me delta z. Clear? And this one is what? Current, that is given by this one. Clear? Now I of z comma t minus में the current going in this direction, g into में delta z v of z plus z delta z comma t minus में c into में delta z dv by dt minus में I of z will be equal to 0, because if I say I of z comma t, let's say if I say I of z comma t will be equal to what? If I this one is say I1 plus में I of z plus में delta z comma t. So similarly, if I said this one, then you will get the minus, and this will be minus. Now see, from equation number I can say that take the r into my delta z and l into my delta z on this side, on the right hand side. You will see that v of z plus delta z comma minus of z comma t can be written as this one. On now see, take the delta z as common, you will get the this one equation. Now when you will get this equation, this will be, this what represents what? Delta v by delta z will be equal to minus of r z comma t minus में l into में delta I by delta t. Similarly, on taking delta z common to this side, and this one represent the delta I z comma t divided by delta z will be equal to minus z into में v of z comma t minus c into में del v by del t. Now see this one, this represent, if I say del by delta t is equal to j omega, then I can say that del v by delta z will be equal to minus of r into में j omega L I of z comma t. Now see, instantaneous voltage can be represented in this form, v of z comma t real part of v of z equal j omega t, and current will be represented in time domain, that is real part of I of z equal j omega t. Now replace del by delta t to j omega, you will get dvz by, if I take the only the in planar form, voltage and current will be in the planar form, expressed in phasor form, dv by dz will be equal to minus of r plus में j omega l iz, and diz by dz will be equal to minus of g plus में j omega c vz. You will see that v of z equal to minus of r plus में j omega l I of z. Similarly, di by dz will be equal to minus of g plus में j omega c vz by dt. I have taken the minus as a common to both. Now see, these are the two equations, voltage and current equation on the transformation in phasor form. Now differentiate these two values, differentiate this equation, this one, differentiate equation number 7, differentiate this equation number. When you will differentiate this equation, you will get what? On differentiating this equation, you will get d2 vz by dz2 will be equal to minus of r plus में j omega l di by diz by dz. Now putting the value of di by dz from equation number 2, from equation number 8 to here. Now on putting di by iz, putting the value of di by z dz, that will be equal to minus of g plus में j omega c vz. You will see, put this value in this equation, you will get d2v by dz2 will be equal to gamma square vz. That will be on this one, you will get, this one is the transmission line equation and this one is the wave equation, and here what gamma represents the propagation constant, and this gamma square is equal to what? Root of this gamma square will be equal to root of r plus में j omega l into में g plus में j omega c, and this gamma is equal to what? Real part plus में imaginary part, complex value gamma propagation constant is the complex value, that is alpha plus में j beta. Clear? So this similarly another wave equation in the terms of current, that is d2iz by diz2 equal to gamma square I of z. Now on this, these are the partial second order differential equation. On solving the second order differential equation, solution of this second order equation will be equal to v of z equal to v of plus e के पावर में माइनस गामा z प्लस में v of माइनस e और गामा z, and I of z equal to I of plus e की पावर माइनस गामा z प्लस में I of माइनस e और गामा z. What does v of plus represent? And e की minus gamma z, e और gamma z represents e की power minus gamma z, and gamma z represents the wave propagation plus z direction. This represents the wave propagation plus z direction, and this represents the wave propagation minus z direction. Similarly, this VO plus represents the wave amplitude of incident voltage, and VO minus represents the wave amplitude of the reflected voltage. Similarly, IO plus represents the current amplitude in the positive z direction, and this one IO minus represents the reflected amplitude of the reflected current, and this one is the negative. Clear? Now see, similarly another equation. Now see, if I take the double derivative of this one equation, you will see that T2IZ will be equal to DZ2 equal to minus of G plus में J omega C into में D of VZ by DZ. Now put the value of dVz by dz from equation number 7. Clear? Now when I'll put this equation putting the value of v of z from equation number 11, you will get what? You will get the another differential equation, that is d2iz by dz2 equal to minus of gamma square I of z, and this I of z solution of this differential equation will be equal to this one. Clear? Now another method for finding out the I of z will be equal to, as we know that this one is equation number 7, dvz by dz equal to minus of r plus में j omega l I of z. Put the value of v of z from this equation. Put the value of v of z from this equation to this value. Now on solving, on taking the derivative of with respect to dz will be equal to gamma into में minus of v plus e और minus gamma z plus में v of minus e और gamma z will be equal to minus of r plus में j omega l I of z. So taking the I of z on one side, you will get gamma upon में r plus में j omega l will be equal to this one. Now see, I of z will represent what? V of z divided by r. So divided by z naught, with this z naught represents the characteristics impedance of the transmission line. So z naught will be equal to what? R plus में j omega l upon में gamma. So z naught will be equal to r plus में j omega l divided by gamma, and put the value of gamma here. Gamma is equal to what? Under root of g plus में j omega c, r plus में j omega l. Put the value of this one, you will get z naught, that is characteristic impedance of transmission line, will be equal to under root of r plus में j omega l divided by g plus में j omega c. Clear? Now this Z0 is the characteristic impedance. This will also be equal to VO plus divided by IO plus, and this will also equal to VO minus divided by IO minus. Clear? As it is reflected, so IO minus reflected will be equal to minus of IO naught. Clear? Now in time domain, this voltage form is expressed V of Z comma t equal to real part of V of Z. Put the value of VO plus this one. Now real part is gamma equal to alpha plus में J beta, equal minus alpha Z, equal minus J beta. Now taking the real part, you will get VO plus e cos of omega t minus beta Z plus में phi plus into equal minus alpha Z. Another from this equation, real part will be VO minus cos of omega t plus beta Z phi f minus. This represent traveling wave along minus Z direction, and this represent the traveling wave along the positive Z direction. Now see, similarly, phase velocity is equal to what? dz by dt. Put the value of Z, that is omega t minus constant, you will get this one. Now from this equation, from this graph, as we know that the graph of e or alpha Z will be as Z increases, e or alpha Z increases, and Z as Z decreases, Z increase, alpha e minus alpha Z decrease. So from here you can also conclude that as the value of Z increases, you will see that the standing waves, amplitude standing waves also get increases. Clear? Now this is special case for a lossless transmission line. For a lossless transmission, R equal to G equal to 0, when there is a no loss. It means there is a transmission line is lossless. That means R, it is ohmic losses, will also be equal to 0, and the conductance per unit length, which is inversely proportional of R, will also be equal to 0. So gamma equal to alpha plus में J beta. Put the value of R equal to 0, G equal to 0. You will get gamma equal to J omega under root of LC. Now this gamma is equal to what? Alpha plus में J beta. Now you will see here that on comparison you will see alpha equal to 0 means attenuation is 0, and phase constant will be there, that is beta equal to omega root of LC. Clear? So attenuation will be 0, as I know that this is a lossless transmission line. So Z0 will also be, as we know that Z0 equal to what? R plus में J omega L divided by G plus में J omega C. Now put the value of R and G is equal to 0. You will get Z0 equal to characteristic impedance, that is Z0 equal to root of L by C. Clear? Now on putting the wavelength, that is 2 by beta, put the value of beta here, and phase velocity, that is omega by beta. Clear? So overall the solution for the transmission line is equal to V of Z equal to E V of plus. This one is for the lossless transmission line. But real part is 0, means alpha equal to 0, means there will be a gamma equal to what? Gamma is equal to J omega beta, or you can say gamma equal to J beta. So V of plus equal minus J beta Z plus V of minus equal minus J beta Z. I of Z similarly equal to V of plus divided by Z0 minus of V of minus upon में Z0 E के बाद में J beta Z. Clear? Now see, next one is the terminated lossless transmission line, when there is a terminal impedance here. Clear? Now see, if I say this one is a transmission line and this has a terminal impedance, that is ZL, load impedance, that is denoted by ZL. The voltage appear at the load, that is denoted by VL. Assume a voltage is applied it here, and let's say this one is Z equal to 0. So this, if I say this one is the length of transmission line, so at the source end that will be equal to minus of L. So let's say assume that the voltage source is appears at Z is less than 0. Incident voltage will be in the form of VO plus equal minus J beta Z. Similarly, then the solution for the lossless transmission line with the termination, that will V of Z equal to VO plus equal minus J beta Z plus V of minus. Similarly, same equation will be there. Clear? Now next topic is the reflection coefficient. Now this one, reflection coefficient, is what this is the reference is SM LIO micro device and circuit. From this I have prepared the slides. Thank you.